Okay, take 1000 of this video. I seem to be having this video is clearly cursed because I did about half of it and then I realised I was missing a page, so I had to jump on my laptop and add a page, and now my dog is scratching at the door, so it's destined to be cursed. So I'll do my best to get through this quickly so you can get into 6D. So 6D in your textbook is looking at seasonal indices. So right back at 6A, we were looking at some graphs, and one of those particular graphs had a seasonal effect within the graphs that you had to pick up on. And the reference to that is when you've got a time series plot that exhibits regular rises and falls within the time frame of a year. So what I mean by that, if you're looking at 3 years and it was rising every summer and falling every winter, that would be a seasonal effect, or we call that seasonality. An example of that might be if I had an ice cream shop. So obviously I'm going to sell more ice cream when it's hot. So during summer, I'm going to sell more, and then during winter, it's going to fall. So this part here, so deseasonalization, is a form of smoothing. So we've had a look at a few different types of smoothing so far. So deseasonalization is another form of smoothing which takes out the seasonal effect of the data, so we can, and the goal of this is to fit a trend line similar to what you've done in the previous chapters of data, and we can make predictions, which is called forecasting. This is really, really important in any sort of business, to be able to forecast staff, buy appropriate equipment and, make money, basically. Now, in order to do that, we need to consider seasonal indices. Now, this is based off the average of the year. So seasonal indices for each of your seasons is based off the average for the year. All right, and I'll get to unpacking that in a second. By the way, this is just from your notes, so your teachers will give you this. So don't stress if you don't have this yet, you will get it. So a seasonal index compares a particular season to the average season. Seasons could refer to a day, week, month, or quarter. All right, so it's not just the seasons of how you think about it, like winter, summer, spring, blah, blah, blah. It could be if you've been given the sales figures for a whole year in months, like January to December, we would say the number of seasons in that particular example is 12. So it's however many time frames you are given. All right, hopefully that makes sense. If you're given 52 weeks worth of sales, you would say there's 52 seasons in this particular time series data. So I'll get to calculating and working out all these in a second, but it is important for you to know how to interpret seasonal indices. So for example, a seasonal index of 1.0, if we interpret that as a percentage, that's 100%. So that means that particular season is smack bang the same as the average season, sales or whatever, right? So it's just pretty average. No less, no more. If you've got a seasonal index of 1.6, that converts to 160%. So remember, your baseline is 100%. So 160% is 1.6 times the average season. So our sales figures are 60% above the average season. So it's a peak or a high season. So if I had my ice cream shop, that would probably occur in summer. And then the other one there, 0.7, which is 70%. So remember, my baseline is 100, and if I'm at 70%, that means it's 30% below the average. So it's a trough or a low season, okay? So that could be my winter if I'm looking at an ice cream shop, all right? So that is interpreting seasonal indices. This is very different to adjusting for seasonality, which can be quite tricky, which I'll explain in a separate video. All right, so here are the steps to deseasonalizing time series data to create a trend line. I'm not going to go through the steps. I'm just going to go through it in an actual example so you get the idea. But I will be following these steps. I just won't be referring to it here. Okay, let's have a look at an example. So these two equations are in your notes, which are just above that I've moved from. So if you're like, where have these come from? I need these. They are up there. They're just green. I've taken them from your textbook. So deseasonalizing data, if you've got your actual figure of your data and you want to take out the seasonal effect to see the underlying where you are from the baseline. So to take out the effect, that huge effect of it being summer, take off that peak. It is your actual sales figure divided by the seasonal index for that month. And that will take off the peak or trough of that particular seasonal effect. If you've got the other way around, where you've got the deseasonalized figure, so you've got the sales figure without the seasonal effect, and you want to re-seasonalize it, so put the seasonal effect back in, you get your deseasonalized figure and you times by your seasonal index. All right. Now, I'm going to start from the start where I don't have any seasonal indices for this particular data. So this following table shows the number of houses sold each month for a real estate in a small town. So we've got January to December, 12, 13, 14, 17, 18, 15, blah, 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 blah. Calculate the seasonal index for each month. So your first step is you want to calculate the average for the whole year, right? So I've got 12 months worth of data there. So I've got 12 seasons, right? To get my average, I'm going to add all these numbers together. So 12 plus 13 plus 14 plus 17 plus 18 plus 15 plus 9 plus 10 plus 8 plus 11 plus 15 plus 20, and I'm going to divide by 12 because I have 12 seasons. If you've got 7 seasons, you add up your 7 numbers, divide by 7. If you've got 8, you add up your 8 numbers, divide by 8. Get it? All right. So I got 13.5. Hopefully I've added that up correctly. I'm pretty sure I have, but forgive me if I haven't. So all I've done again is I've added up each of the sales figures for the year and I've divided by how many seasons I have, which is 12, so 13.5. So that's your first step. You got to find your average for the year. So the average sales for the whole year was 13.5. And just look at the rounding instructions for the particular question. Right, so for each of the months, I'm going to divide the month by the average. So for example, for January, I'm going to go 12 divided by 13.5, which equals we'll say, I'll go 2 decimal places, so 0.89. And then I continue this process. So February, I've got 13 divided by 13.5. So this one, I've got 0.96. And then I keep going. So March, 14 divided by 13.5. I'm going to continue this and finish it off. And then I will come back and have all the answers for you. All right, I'm back and I've worked out all the seasonal indices for each of my months. So again, all I've done to work those out is I've taken each month, looked at the figure given in the month, and I've divided it by the average that I got for the whole year. So the average was 13.5. So the first one there was 12 divided by 13.5. Now, if you think about it, if the average is 13.5 and I've got a number lower than that, I'm going to have a seasonal index less than 1 because the number given here is less than my average. If it's higher than 13.5, for example, for April, 17, if I look at April, 17 divided by 13.5, I've got 1.26. So this is above average, all right? So interpreting these, for example, if I'm interpreting April, I'm 26% above my average in the sales for April, whereas my sales for October, if I have a look at October, 11 compared to 13.5, so 11 divided by 13.5 is 0.81. So the difference between that and 1 is 19%. So that means I'm 19% below the average for October. So that's interpreting your seasonal index. All right. If you've ever got the situation where you've got multiple years, you have to treat each year separately. So get your average for the year, get your seasonal indices for that particular year, and then go on to the next year and treat it like it's separate. And then once you've done that for all your years, then you get the average of each of the, like if we're looking at months and I've done 3 years, I would look at all my January seasonal indices and I'd get an average for those. All right. So if you've got multiple years, treat them as individual years and go from there. That appeared in an exam a few years ago, so you will definitely need to know how to do that. All right. So question, now that I've got all my, a big thing to note, to check that you've done the right thing, your seasonal indices should add up to how many seasons you had. So if you add up these 12 numbers, you should get very, 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 very close to 12. And I've just had to round something slightly up just to make sure I was smack bang on 12. But you should get like within 2 decimal points of the number of seasons. So if you've got 4 seasons, your seasonal indices should add to 4. If you've got 25 seasons, they should add to 25. In my case, I've got 12 seasons. They're going to add to 12. So that's a good way to check. Also, if you're missing a seasonal indice, it's very easy to work out what it is because it will be how many seasons you got less all the ones that you've got there. So it's very easy to work out. Anyway, question 2. So if in the following year the real estate sold 17 houses in November, deseasonalize this figure. So we're using this equation here. So the deseasonalized figure is equal to the actual figure over the seasonal index. So the actual figure is 17 and our seasonal index for November is 1.11, which equals, so the deseasonalized figure for November is 15 point, we'll go 2 decimal places, so 15.32 without the seasonal effect. So the seasonal effect of November is adjusted, we're 11% higher. So without the seasonal effect, if we're selling 17, that would be adjusted to 15.32. All right. Now, question 3. The deseasonalized sales for the month of April was 9. Re-seasonalize this figure. So I have the deseasonalized figure here. So I'm looking for the actual figure. So the actual figure is your deseasonalized figure times your seasonal index. So it's putting the seasonal effect back in. Up here it's taking it out, here it's putting it back in. So the deseasonalized figure for April was 9, and the seasonal index of 9 was 1.26. 1.26 times those together is 11.34. 11.34. So the actual sales figures would have been 11.34 approximately. Okay, so once again, if you're deseasonalizing, you're taking the seasonal effect out, so dividing by the seasonal indices index for that particular season, and then if you're re-seasonalizing it, you're putting it back in, so you're multiplying it in. So again, remember your seasonal index must add up to how many seasons you have. For example, this one here, I have four seasons here. So these four numbers, so 0.8 plus 0.7 plus 1.3 plus x have to equal 4. So if you want to, you can use solve if you like, or you can just add up those three and take it from 4, up to you how you do it. So the missing number is 1.2. Alright, so that is seasonal indices, how to calculate seasonal indices, working out how to deseasonalize a actual figure and putting the seasonal effect back in if you've got deseasonalized figures. Hopefully that has helped. Now there could be a step here where I think it's up here in your notes. So for example, if you want to have a look at, you've deseasonalized all your data and then you want to put it in a graph, you would follow this step here, but that comes up in 6E, which I'm going to do a separate video on, so that we're not quite up to that yet, but just pay attention if the question is asking you for the deseasonalized sales or the actual sales, etc. So just pay attention to the question. I'm going to do a separate video on this here, correcting for seasonality, because it's a little bit tricky. So I'll do that separately. Thanks for watching.